Alright, let's go ahead and get started with the NumPy coding part. So we have here our array. We are gonna get started with the NumPy array first, and these are the function which we are going to cover in this lesson. We will be seeing what is NumPy arrange, what is NumPy zeros, what is NumPy ones, and NumPy linspace. All these are used here to create NumPy array. We can create NumPy one-dimensional array, two-dimensional or multi-dimensional array like 3D and 4D. It would be really very difficult to visualize four-dimensional array, but you can obviously visualize the three-dimensional array something like this. We will be also trying to understand the array data types, typecasting, indexing, slicing, and modifying the elements. All this stuff we are gonna cover in this lesson. Alright, let's see how you can first of all define a NumPy array. So you have here your NumPy imported as NP, and thereafter to define array you call NumPy method, that is the array. So you write here NumPy dot array, so it becomes here NP dot array, and thereafter inside this you need to tell here that your items here. So I have row 1 and row 2 data. So that is defined as a list here. So in row 1 I have 1, 2, 3. In row 2 I have 4, 5, 6. And these things what you see here internally, all these are actually values for the array here. And as many list here you define, you can say that many row it is going to have, and each items in the list, this says that many column your array is going to have here. A one-dimensional array can be defined, or it look like something like this, where you have just a vector representation for your numbers. And two-dimensional NumPy array look like something like this, which you can understand something like a matrix representation. And a three-dimensional array look like something this, so it is like a cube representation. So in this you have here length, you have a width, and you also have here a height. So you can say that here this one is the first axis, you can say this is row, here you have the column, and what you see here at the top, this you can say that as the third axis or the height, something like that. Okay, perfect. And now you notice here these shape. So this one-dimensional array have only one shape here. Alright, and it don't have anything related to column because it has only rows here. You cannot say that these are column. One way you can say that this is like 1 cross 4, but generally it's not called like that. This is completely just a row vector actually. And here the two-dimensional array have a shape of the 2 cross 3. That means it has 2 rows and 3 column. So when you see in shape, it says that the first number is actually the row and second one is a column here. Similarly here in this, the first one is row actually. So basically this one is row, and then 3, that is the column. So this one is the column, and this 2 you can say that what you see here, this is actually the depth of your array. So this whole thing which you see, this is a kind of your matrix representation, two-dimensional array. And if you combine a multiple two-dimensional array, then that array becomes a three-dimensional array. Alright, so this is overall understanding how this overall array is defined in NumPy. Let's go ahead and import NumPy and thereafter create a NumPy array. So I'm just going to simply write here import NumPy as NP. This is like standard convention to import NumPy as NP. Thereafter I'm gonna create here array, the first array. So I write here D1, that's the one-dimensional array. I write NP dot array as I defined here earlier. So it's something like this, NP dot array, and then inside this array it needs here an object here. So what object we can give? We can give here a list, something like this, 1, 2, 3, and if you see here your one-dimensional array, it has here one-dimensional value basically 1, 2, 3. You can check the shape of this by typing their shape. There you will notice this is 3 comma nothing. That means it has a 3 columns here basically. I mean it's a row vector only, but total number of element in that vector is actually a 3 vectors there. Alright, that's how you see there. This is one-dimensional vector. How you can do the two-dimensional vector? So I define here a 2D or D2 actually, np dot array, and now inside this you can pass here a multiple object here. All right. So the multiple object, basically you can pass here a multiple list. Basically you can do something like this: 1, 2, 3, and 4, or let's make it 3 only. Thereafter another, again comma, and then you can pass here another object, and that object you say here that 4, 5, and 6. But if you run this, it's gonna throw the error, because this whole thing you have to make as a single item. All right. So for that you have to put it here you have to put here a nested list actually. So these are individual items inside the outer list, and then these things which you see here, these will become a single row, and these will get combined vertically here. Now you will notice this D2, if you print this D2, this is gonna work something like this. So you have this, and then it has actually combined this vertically to your this list here. Now you have 1, 2, 3, 4, 5, 6. Similarly, if you check the shape of this, you will be having shape of 2 and 3. So the 2 and 3 means you have 2 rows there. Let's go ahead and print this D2 for better understanding. So here it says that you have a 2 row, 1 and 2 row, and 3 column, 1, 2, and 3 column. So that's how you define the 2-dimensional array. Similarly, you can define here a 3-dimensional array. So you can do like this: D3 is equal to np dot array, and inside this you can put here a list, inside again a list here, and that I'm gonna put here 1, 2, and 3, and thereafter again here I'm gonna put here not 1, 2, 3. In fact, it would be better to tell here 4, 5, and 6, and thereafter again here I'm gonna put here 7, 8, and 9, not like this one. All right, something like this. So now one thing you will notice here, that this is not actually the 3-dimensional array. This is just a 2-dimensional array. So what do you understand with this? So while creating this 2-dimensional array, we had actually created a nested list. All right. So you can say they are a nested list. But here for 3-dimensional, we again have a same kind of list like we have a 2-dimensional array. That is why it is coming here as a 2-dimensional array. To make it 3-dimensional array, you have to create again here, even you have to nest it, even, even more you have to nest it. So like this you can nest it. You can put it like this. So these two items you can put as, a single list here. All right. Now this thing will be a single 2-dimensional, and again, this thing what you are seeing here, this could be the another, the single, this whole thing which I'm gonna define here, this would be a 2-dimensional array basically. So I'm gonna put here 2 and 3 like this. Now if you check it here, so you will notice that now this becomes a 3-dimensional array. You can check the shape of this. I'm just gonna print it, and then I'll explain actually what is happening here. So D3 dot shape, and now you will notice here 2 cross 2, and then there is a 3. So it has here 2 rows, 2 column, and there is a depth of the 3 items here, or the 3 layers there. So what happened here, you can say that to create 3-dimensional array, you can create a list of 2-dimensional array. All right. So we are creating here a 3-dimensional array. So we took here a list of the 2-dimensional array. So this whole thing which you are seeing there, this whole thing is actually a 2-dimensional array. All right. So this whole thing, right? Do you notice here that all these are actually the 2-dimensional array? All right. So to create here, not this one actually, yeah, here this one. So this one is 2-dimensional array, and here this one is 2-dimensional array. How you can define that? You can say that np dot array. So this whole thing you can put here as a single 2-dimensional array. Similarly, you can say here np dot array, and here this one. So you have this one and this one. So now you combine all these together. That's what we are doing here. So once you combine multiple 2-dimensional array together, that becomes a 3-dimensional array. And similarly, if you combine there a multiple 3-dimensional array, then that becomes a 4-dimensional array. Similarly, we had done previously, you combined here a multiple 1-dimensional array, this one and this one together, that becomes a 2-dimensional array. So I'm sure you have understood here the hierarchy. You combine 1D multiple times, that becomes 2D. You combine 2D multiple times, that becomes 3D. And you combine 3D multiple times, that becomes a 4D. Alright, this is all about in this lesson. We will continue this in next one. Alright, now let's see how you can create this array using other methods. So as of now, we have been creating it using a list method. Now we are going to see how you can use here range method to create these array. We already know how to use this range method. Suppose that we are going to create like 1 cross 3, something like this. And if you put it inside array, something like this, np array and like this, and you run it, now you are getting here 1 and 2. If you put it here 5, 1, 2, 3 and 4, and similarly if you put a multiple range here, you would be getting something like this. You have to actually put it inside a list so that you can make here a list of one-dimensional array. Alright, perfect, something like this. So one thing we are already sure that previously, if you make a list of the list of one-dimensional array, then that creates a two-dimensional array. Similarly, list of the two-dimensional array, that creates a three-dimensional array. Similarly, if you make here a list of three-dimensional array, then that creates a four-dimensional array, and so on. Alright, this is standard, how to create these dimensional array, multi-dimensional array. So this is one way to create your array using range method, but there is even more simpler method, and that comes here with NumPy itself, that is the arange method. So that is like array range method. That method you can also use here. So you can write simply np.arange, and thereafter if you put your cursor here, it will show you a complete function definition to you. So it says that it needs start, stop and step size. Alright, so from where you want to start it, from at where you want to stop it, and what is going to be the step size for this arange array. Alright, so you can simply do here np.arange. I'm going to say that start it from 0, stop it at 10 with the step size of the 2. If you just run this, now you are getting here a NumPy array. So with the range method, I had to call here np.array separately, but with np.arange method, you don't need to call this array separately. So this array automatically comes here with the arange method. Let's see how you can create a multi-dimensional array using other methods. So we have zeros, we have ones. So all these methods you can also use to create your NumPy array. For example, if you want to create here like 2 cross 2 zero array, how you are going to do zeros array? So you can simply write here np.zeros, and there you can put the shape for which you want to create the array. So what is the shape I'm going to put here? That is the 2 cross 2. So now it becomes here np.zeros, and the shape is here something like this. Alright, and if you just assign here with some z2, that's the 0 2-dimensional array, and you check here the shape of this, you will see the shape is 2 cross 2. And similarly you can check here the data type as well. So the data type here, default data type is float 64-bit. That means the default number of bytes used here to represent the data, that is the 8 byte, or you can say that 64-bit representation is used here. You can also define here the data type while creating this zeros. So you can say that the data type, and you can define here integer. So now it's going to generate it here in integer format. You can define here integer 64 as well. So it is going to generate this zeros array. If you just print this, I'm just going to print it. Now you will notice here that this has been generated as a integer data point here. So that is how you can use this zeros to generate the array. Let's see how you can use ones to generate the array. So you can similarly use their, let's say O2 I'm just going to use, so that I can say that this is ones, np.ones. So what is this ones? So ones are actually basically, these are the type of array which will fill all the values inside the array with the identity matrix, not identity matrix, but in fact with actually the one value. All right, so you can say that here once 2 cross 2, and thereafter if you check this O2, this is going to give you something like this. Similarly, you can define here the data type as well. So I'm just going to say here the data type is going to be the integer. A default integer is actually a 32-bit. You can similarly check here O2 dot D type, and this says that this is integer 32. Alright, so where these zeros and ones are useful, if you are creating any if you have an array and you want to do some kind of the manipulation, and you just want to do some manipulation on some particular set of the index, at that point these could be a very helpful. Later on throughout the course we will do these kind of these kind of the manipulation sometimes, where we will be generating some the dummy array, and thereafter we will try to merge those together or something like that. But don't worry about that if something you don't understand that why we are doing this. But don't worry about that, later on once you complete the course you would definitely understand that why we are doing this. Alright, let's see how we can do the indexing. Alright, suppose that we already have our array, a little bit larger array. We have D1, D2 and D3. So let's say here you have your D1 array. Now the question is here how you can do the indexing, and then how you can change the data type. So that part we are going to see in next lesson. As discussed, let's go ahead and see how you can do the indexing here. So we have a little bit larger array D1, and we also have here D2. So we are going to first do here how you can do the indexing of the one-dimensional array, and then we will see how you can do the indexing of the two-dimensional array and then three-dimensional array. So to understand this, we'll start with D1, and let me just explain you with an example this here. I'm just gonna open here a notepad. Suppose that you have a array, one-dimensional array, something like this, and currently it has a 3 value. Those values are I think 0, 1 and 2. So this one is one-dimensional array. In one-dimensional array, this is at the index 0, this one is at index 1, and this one is at index 2. Alright, and what is the total length of this? Length is actually the 3. That means the total number of items inside this array is actually 3 here. Alright, and let's say this one is defined as some variable as D1, and you want to take here some this value. Alright, and what is the index of this? That is the 1. Alright, so what you will write here for this one, this will be defined here D1 and 1, and for the second one it will be defined here D1 and 2, and for this one it will be defined here D1 and 0. So using this indexing method you can actually index your array, NumPy array. Alright, let's see with the example how we are going to do this here. So I'm just gonna create here array for your understanding that how we are going to understand this. Well, so you have here your array something like this, and it has 1, 2, 3, 4, 5 and 6 value here. So this thing what you see, this is known as a row. Alright, and here what you see, this is known as a column. And row indexing, you can say that this is 0 and this one is 1, 0, 1 and 2 for the column indexing. Hypothetically assume someone is saying that you need to find out that value which is at row 0 and column 1. So which value is this? You need to find out. So the row 0 means you have this one. Alright, so it comes with this one. So this is actually row 0 means it is saying that this whole row which you are seeing here. And then you have a column 1. So the column 1 is this one. So what you see there, the row 0 means this whole thing, and the column 1 is this one. So where it is intersecting? At this point. So you will say the result is actually 2 here. Alright, then it says that the result is 2 here. Similarly, if someone says that you need to find out at row is equal to 1 and column equal to 2, what is going to be the value here? So the row 1 means it is saying that this row. Alright, here you have row 1, so this one saying that this particular row. Alright, so in this way what happens here, you have this row, this whole thing is getting represented, and then this column 2 you have this whole thing is getting represented. So where is intersection? Intersection is here. So the value is going to be 6 there. Alright, so you will notice here that value becomes 6. So that is how you do the indexing of the two-dimensional array. So what you have to define for two-dimensional array? You have to define row along with column together if you want to index two-dimensional array. Let's see how this works here. So you have 2D and let's say you want to find out this 3 value. So where it is currently sitting? So this third value, what you see at the 0th row and second column, or 0th row and second index column. Alright, so you can say that here D2, and then inside this D2 you can say that this is sitting as actually 0, 2. So this is going to be final result. What you see there, that is the 3. This thing is coming from this print, and here at the output coming from this. So you see the 0, 2. Let's see, now you want to find out this particular value. So what will be index here? So at which row this comes? That is the first index row, right? That's the second row actually. So you come here at the first index row, and this one is also coming here the first index column, that is the second column. So you define here D2, 1 and 1. So with this you are gonna get there a 5 as the result. Now you will notice you are getting here result as a 5. So that is how you can do two-dimensional array indexing. Let's see how you can do the three-dimensional array indexing. So three-dimensional array is a little bit complicated. Just to understand this, we are again going to take an example here so that I can explain you this properly. So in a three-dimensional array, what happens here? So your three-dimensional array is actually, it is array of the two-dimensional array here. So what happened here? This is actually the list of your multiple 2D array. Alright, something like this. So let's say you have a three-dimensional array, which is this one, and you want to index this particular, the value. How would you do that? So this is a 0th index and this is at the first index. So you will say that whatever the D3 is there, you will say there a D3 1 is actually representing this particular thing. Alright, and similarly you will see here D30 is representing this thing. Now this becomes a two-dimensional array, right? Now all these are a 2D array. Now you can apply there the 2D indexing kind of things to get the output. Alright, so to work with the three-dimensional array, you have to first find out your index for which two-dimensional array you want to understand. You want to actually extract the value. Thereafter you can use the two-dimensional array kind of indexing. For example, let's say you want to extract this 6 value, then how you can do that? Alright, so to extract that, first you have to make sure that which two-dimensional array we are referring. So we have currently here two-dimensional array, this one and this one. So we are referring here the first two-dimensional array that is sitting at index 0. So you say there the D3 0. That is how you get there. Thereafter you say that you want this 6 value. So this we already know that how you can index two-dimensional array. So there is a 0 and 1. So this is going to be the second row. 0, 1 and 2. This is going to be the third column. So you write here something like this. Second row. Alright, second row means the index is 1 actually there. Something like this. And then the third column is index is 2 there, like this. And now you run it, you have got this result like this. Or you can just simply write here a D3 and then you can say that the 0, 1, 2, and that is also going to give you the same result what this thing is going to give you the result. Alright, so that is how you can index your three-dimensional array. Let's quickly see that how you can change the data types. Alright, so we already have our data type for D3. Let's say currently what's the data type here, you can just check that with the D3.d type. It says that int 32. Let's say you want this data type as the float. How you can do? Now it's pretty much simple. Again, you can just simply write here, let's say I'm going to write here D31 is equal to D3f, actually that becomes a float here. So D3f is equal to D3 dot, and then you can simply write here as type, with the as type integer or float, whatever you write there. So it is going to convert this as the float data type. If you check your D3f, now you will notice here that this has become the float data point. You can similarly check its D3f, you can check its data type as well, something like this, D type. If you run this, you will notice here that this is a float data type. Alright, so this is all about in this lesson. I'll see you in next one. Alright, let's go ahead and see what is NumPy NaN and NumPy INF numbers. We are also going to see that how these are different than others. Okay, let's try to understand that first of all, how these things are different to each other. So this NaN says that this is not a number. Alright, so basically it says that in floating point calculation, generally these two things are used. So when you get NaN, np.nan, then that means it is not a number. So basically whatever result you get there, that cannot be defined as the number. And INF is something which is infinitely small or infinitely large number. So what you can understand here, that if something 1 by 0, then this produce a result of like np.inf. Alright, so this is like np.inf. And 0 divided by 0, so this thing cannot be done actually, right? So this is like 0 divided by 0, that is going to produce np.nan. So it says that, so this thing cannot represent a number, but this thing represents number, but the number is very small, that is infinitely very large number. And other operations you can see here, like if you do np.inf plus 1 or any number, right, or any number is going to produce a result that is still np.inf. Alright, and similarly if you do here np.inf and then again plus inf, np.inf here, alright, then this is also going to produce their np.inf. But if you write something np.inf minus np.inf, then this says that not a number, so that becomes np.nan. So what do you understand with this? So if you subtract something from a very large number, right? Let's say infinity here. So infinitely large number is getting subtracted from infinitely large number. Then the final result come here that as a not a number. So basically whatever result you get from this, that cannot be defined as the number. So these are the some of the difference between these. Any NumPy array can have these kind of values inside that. Earlier we had seen our D1 NumPy array. Inside this array you can have either infinitely large number or not a number, or you can have a both together. Let's go ahead and try to define that. So I'm just going to say that here number is equal to, or nums is equal to, that's the number, np.array. Inside this I write 1, 2, thereafter np.inf. Now this becomes infinitely very large number. Now if you check here, you can get your number here. So one more thing you will notice here that, so these type of number, these two type of numbers are used here in a floating point calculation. So this automatically change your data type into a float data type. Alright, if you define your data type here, let's say you define here integer data type, you are going to find out their error. Why? Because this number np.inf cannot be represented in an integer data point. That is why you are getting there an error. All right, I'm just going to comment that so that you can have this later on in this notebook. So you can have something like this 1 2 np.inf. Okay, so this thing if you define as a float, then you would be able to get it correctly here, because this inf what you see there, this is actually the float representation here. And if you are given some array and you want to check that if there is any infinitely large number present there or not, you can just simply do that with np.is_inf check. So there are two type of check available with NumPy. Let me just write that here. So the two type of check is that np.is_nan and np.is_inf. So these two type of check you can do. Let's check with the np.is_inf. You write here np.is_inf and thereafter you write your number which you want to test here. Now you will notice this is false, this is false. So in this array which you have here, so 1 and 2, these are not infinitely large number, but yeah, this one is true. That means this particular number is infinitely large number. Or you can do here sum as well if you want. So you would be able to get something like this. So this says that there is a total one element inside this which is infinitely large. This is one way to do that. Another way you can do here is dot. Basically, I'm just going to copy this whole thing from here. And thereafter you can apply here sum as well. So now you will notice here this one. You can comment this one if you want. So these two methods you can use to understand that total how many infinitely large numbers are present there in the data set or in the NumPy array. Let's go ahead and see how you can generate NumPy nan together, NumPy nan with the NumPy inf numbers together. So you are gonna write here nums2 is equal to np.array. Again, this is going to be list here 1, 2, let's say 3, 4, and then I write here np.inf, then np.nan. Like this, it happens. If you run this, now this nums2, you will notice it is having here inf and nan. Again, you will notice the data type which you see internally inside this array, that automatically becomes here a float data type. You can check the data type here. So data type, that becomes here a float data type. Then you write here nums2. So basically you can check it here if there is inf or nan number. So np dot is nan nums2. So it says that true. That means there is one nan number. All right here. And if you provide there a sum, with that sum you can know that how many number are there. If you have very large NumPy array, and in that you just want to measure that how many actually NumPy nan or NumPy inf number you are looking for, then you can provide this particular check. One thing you will notice here that, let me just copy this and put it here. One thing you will notice that while checking this is nan, you are getting here false for inf. So these two check are different, is nan and is inf. All right. So if you check is nan, it's not going to give you the check for the inf. All right. And whereas this nan will give you the check only for the nan values. Now let's see how you can replace these nan and inf value with the number value. All right. So one way to replace that, to find out the index where this value is present, and thereafter separately you can change those values, right, separately. But there is a function already available with the NumPy. You can use that function directly to make these changes. So those functions are nan to number, so that you can use to change this nan and inf values to the numbers. For example, if you have this nums2 variable and in this you want to make the change, you simply write here nums2 dot nan to num, and thereafter here you need to write here nan not this one actually, I have written it wrongly. np.nan2 number, that's mean nan2 number. Then you write here nums2, and then you say that with what value you want to replace. Let's say I want to replace it with -1. If you just run this, you will notice here that this nan value which you had here, alright, this one, so this got replaced here with the -1 here. The another thing you will also notice here that this INF value which you had here, this also got replaced with a infinitely very large number. So what happened here, this NaN got replaced, but along with that INF automatically got replaced with the highest available value which can be represented with the 64-bit system. So to solve this problem, you can also pass here a couple of more parameters. So those parameters are like, you can pass the positive infinite value you want to clip, or you want to give some positive number. So for that you can say that POSINF, that's the positive infinite number, and I say that whatever you have which is positive infinite number, then replace that with 1000. Right now you see there, this thing got replaced with the 1000. Let's say if you have minus np.inf value as well, then just to keep that as well for a completeness, you can put here negative inf is equal to -1000. So these value which I'm currently replacing, this you can choose as per your choice or as per your requirement in your code. Let's go ahead and run this. Now you will notice here that how you can change your NaN and INF to the numbers. Alright, so this is all about in this lesson. I'll see you in next one. Let's go ahead and see how you can perform statistical operation with your NumPy array. We have our couple of NumPy arrays here, like D1 we have D2. In fact, we also have here D3, which is 3-dimensional array. So we are going to see how you can apply these statistical operation on these NumPy arrays. For example, how you can find out mean, how you can find out median, how you can find out standard deviation, variance, minimum, maximum, summation part we have already seen. And then we will be seeing how you can apply these on a different axis. So what is the mean of different axis? For example, here how you can find out mean along the rows, how you can find out mean along the column, and so on. Alright, let's go ahead and get started with this. So the first of all, I assume that we have our one-dimensional data, which is D1 here. And for this D1, I want to calculate mean, variance, and so many other values. So first I write here np dot mean, and thereafter I can just simply put my NumPy array inside this. So you get the mean of these, which is 2. Always you will get all these statistical operation values in a floating point number. Thereafter you can say that here D1 dot mean you can also apply here. So with this you will be also getting the same result. Similarly, you can also find out the variance as well. So you can apply here np dot variance, and then you provide here D1. With this you would be getting the variance of the D1 value. That is how you can get this. And then similarly you can apply here np, in fact D1 dot variance. So with this you can get the variance here. So these two methods you can use to get the variance. Similarly, you can use here np dot standard deviation to get the standard deviation, that is the STD, and in that you are gonna provide here np.std, which is a D1 here. So with this you got the standard deviation like this. Similarly, like we did earlier, you can also use here d1.std to get the standard deviation. You run this, you will find here these two values are same like here we had. Similarly, you can find out the minimum and maximum. So for that purpose, I'm going to use a new cell actually. So instead of that, this one I'm also going to put in a new cell. So it would be better to show these, So this becomes like this, and for this you have like this. Then you can simply use np dot minimum and then provide here a D1. So you have a minimum of, the D1 is 1. or you can provide here d1 dot minimum. So the minimum of this d1 is again here 1. Similarly, you can use the maximum, so np dot max, and then you have here d1. So the maximum of this array is 3, and similarly you can have here np dot in fact d1 dot max. Now you have the maximum of this, the dimension, that is the 3 here. Alright, so that is how you can use the NumPy statistical operations or NumPy statistical methods. Let's see how you can apply this on a two-dimensional array. So the same funda you can actually, the same fundamental you can use for the D2 as well. So you have here D2 and then D2 dot mean, and then I'm just going to change it here to D2 and like this. Now you will notice here that even though this is a two-dimensional array, if you print this D2, you will notice this is two-dimensional array. Even after that, you are getting it a single value for the mean. Alright, so these are for mean and these are for the variance. So why is this possible? You see, what happened here, if you don't apply on which particular axis you want these operations, it is going to give you these operations on whole data set. So basically it first, it first actually flatten this two-dimensional array into one-dimensional array, and then it applies these operations on that. So you will notice if you add all these together and then you divide by total number of values here, that is 6, you will see the total here you will get, that is a 3.5. That's the mean value. Alright, but let's say if you want to apply it on a particular axis, then how would you do that? So to apply it on a particular axis, you can now provide here an axis parameter. So I'm just going to comment this one, and then I'm just going to get for this mean. So I'm just going to remove this so that you can see it properly. So you have here now np.mean, and then you have here a d2. Then you can say that axis equal to 0 here. So the axis 0 means you will get here the mean along the columns here. Alright, so these are the column here. So now you will be getting here all the means along the column. What is going to be mean for this? 4 plus 1, that's the 5 divided by 2, that's the 2.5. For this column you get here 3.5. For this column you get here 4.5. So this is mean along the column, you can say that. Mean along the calls. And how would you get the mean along the rows? So you can just simply write here np dot mean, and then you can write here d2, and thereafter axis is equal to 1. So with this you will get mean along the row. So what's the value here? 6 divided by 3, that becomes 2, that is the mean. And similarly here you have 15 divided by 3, that becomes here 5. So you are getting here all these mean values along the column here. So the same concept you can use for the variance as well. So I'm just going to remove this one and then this one, and now you have here np.variance, and then you have here d2, and thereafter I'm just going to write here axis is equal to 0. So this gives you variance along the columns. So along these columns you are getting all the variance, and similarly you can write again np.variance d2, and then you have here axis is equal to 1. So this will give you the variance along the columns here, along the rows actually. So you are getting now the variance along the rows here. So that is how you can actually use these statistical operations in the NumPy. Alright, let's go ahead and see how you can actually do a feature normalization. So feature normalization is very important, and this feature normalization we will be using a lot in our machine learning algorithm. Suppose that you are given here a data set, something like this, where the features which you have here, those are not in the same scale. You need to bring those features on the same scale. So basically you need to convert these features into like a normal distribution, so that you can normalize these and you can bring the mean of this data set to 0, and then you can distribute the variance along the mean, right? Something like this, like we see in our distribution. So I'm hoping that you should be getting result something like this, where you will be getting a mean that will be along the 0, and the most of the data point distribution will be inside this, where you have this standard deviation like this. Okay, so let's see how you can do this feature scaling part here. Okay, so for the feature scaling, we are going to actually subtract the mean from our data, and thereafter we are going to divide it by the standard deviation. That becomes the normalized data. So you can say that something like this: normalized D2 is equal to your D2 minus NP dot mean, and then you have here D2, and that we have to do here along the column, that's the axis 0. So you get your D2 minus mean value, alright, and thereafter you need to divide it with the standard deviation, that is the NP dot standard deviation, and thereafter you put here D2 and then on axis equal to 0. You just run this. Now you will notice this normalized D2 is now a normalized data point here. Alright. So these most of the values are now, in fact, all these values are now normalized. So if you have a very large feature, very large data set, which we will be handling later on in our machine learning course. So you will be seeing that using this normalization method, we would be able to normalize our features. And this normalization method we will be using directly from the sklearn and other libraries, but overall fundamental concept behind the scene, this operation will be done on that data set. Alright, this is all about in this lesson. I'll see you in next one. Let's go ahead and see how you can reshape NumPy array. So there are many ways to reshape your NumPy array. You can use reshape method, you can use ravel method, you can use a flatten method. But there is a difference between the ravel and the flatten. So basically these two method does the same thing, but the main difference is that this ravel method returns there a view of the array. So that means it does not take the additional memory, whereas the flatten returns the copy of the flatted array, so it takes a lot of memory. Other than that, this flatten array since takes the memory, so this is a little bit slow as compared to the ravel, and whereas this ravel is a little bit faster as compared to the flatten array. But this ravel always does not return the view if memory, if basically this memory, if that array is stored in the contiguous memory, then if it's stored in the contiguous memory, then it returns their view, otherwise then it returns their copy. So you can just understand on the top level that if you use the ravel, then that is a lot faster than the flatten in almost all cases. Now the question is here, if some method returns the view and copy, what's the difference between that? So view is something where it will just returns a view, but if you modify that view, it will modify the original value. Alright, so that you can understand with our D2 array. Let's say you have this D2 array, and if you use here a ravel, let's say I'm using here a ravel. So with this you will notice here that it is being shown as one-dimensional array. Let's say I'm saying it D2 right? So this D2 got converted into one-dimensional array. Now you have your D2 here, and our original D2, which I'm going to print again here, is something like this. But in this D2 I'm going to change some value. Let's say at the 4th index, which is this one, I'm just going to put here a 0. And thereafter, if you print D2 you will notice there is 0. Let's go ahead and print this D2 and then see what happens here. So after printing this D2, you will notice here that at this place earlier, the D2 had 4, but now it is 0. So this is a difference between the view and the copy. So if it was a copy, then the change which you had made here, but not directly in D2, so in copy that change will not reflect in a D2. But we are using here ravel method that gives you a view. So if it gives you view, that means if you make change here in the D2 then that change is going to reflect in D2 as well. So this is the basic difference between ravel and flatten. Let's go ahead and see all these in the detail. So we'll start with the first reshape and shape. So we have our D2 and we can check the shape as usual. It says it has 2 rows and 3 columns. Similarly, we can check for the D3 as well. Although we have done this previously, but just for refreshment, I'm doing it again. So it says that it has 2 rows, 2 columns, and the width is here 3. Let's see how you can reshape this into a one-dimensional array. Alright, and then I'll show you the difference between the reshape, ravel, and flatten once again. So here you have a D2. So this D2, and then you can write here reshape, and then you can say that in which shape you want. Let's say you want it 1 row and thereafter 6 column. So something like this you can say it, right? So you will notice here that this seems like here one-dimensional array, but actually this is not one-dimensional array. You are just changing the shape of your matrix, and if you check its shape, you will notice that it is still two-dimensional array, right? So although it look like that it is one-dimensional array, but if you check the d21.shape, this is one-dimensional array, right? So as many number here you have inside this tuple, that is the shape of your array. That you can understand as a fundamental concept. Okay, so that's what that's what the difference between this reshape and here the ravel. Similarly, you can check with the flatten as well. So let's say I say here d21f. All right, so this is a flatten here. You have here your d2, and thereafter I'm going to use here a flatten. Let's say this one, and if you write it something like this, you have your d21f like this, and if you change this to 0, let's say you are changing here d215 equal to 0, and now you will notice this d21f becomes here the 0. In fact, this one actually I made 0. Now if you check your d2, you will not notice that change here, right? So in this, that 6 got replaced with 0, but here it's not replaced because we are using here a flatten. So flatten returns the copy, but ravel returns only a view there. Alright, perfect. Now let's hypothetically assume you have an image and you are applying some machine learning algorithm on that image and you want to reshape that data. So we just need to generate first image kind of data. So I'm just going to generate here 100 channel image with the 28 cross 28 the pixels in height and width. So I write here as image is equal to np dot random dot rand, and thereafter I say I want here 100 image, and thereafter I want here 28 cross 28, right? So this is something which you have a 3 channel kind of image here. Although you know that you have just 100 image, but all those 100 image have a size 28 cross 28. So here if you check the shape of this array, it says that there is 100 and 100 image, and the shape of those image are there 28 cross 28. But you are applying here ML application like let's say the CNN, and you want to convert this data as the two-dimensional data. So basically currently how this is here adjusted, so you have your image like this, there is hundreds of the image like this, right? Hundreds of images like this. But now what I'm saying, how you want there, you want your image something like this, where you will just flatten this and then you will be having these 100 images like this instead of these the 28 cross 28 image. So currently you are having here 28 cross 28, but I'm saying here you will be having here only 100 cross 784. So this 784 is actually 28 into 28. So this shape is going to be converted here as a single dimension or one dimensional vector space, this image data, right? This image data. So that part you can do here with the images is equal to images dot reshape, and then you can say here that you have 100 image, and all these image size which you have, this one you want to convert these as the single input, single channel, or you can say that as a flatted image data. So for that you can do here 28 cross 28, and thereafter if you check the images shape, then you will find out here that this is converted here 784, like we discussed here, something like this. Alright, perfect. So this is all about in this lesson. I'll see you in next one. Alright, let's go ahead and see how you can generate sequence, repetition and random numbers in the NumPy. So NumPy has these methods to generate these sequences, like it has arrange method. So this arrange method we have already seen. Now we'll be seeing here linspace method, tile method, repeat method. At one instance we have also seen random method. We will be also using here randint, normal and seed method as well. So I'll be showing you how important this seed method is in machine learning algorithms, data and weight initialization. So this is very important. Throughout the course, we will be using this seed method a lot whenever we do random initialization of the weights or the data splitting. At that time, we will use this random seeding there. So this part is very important. Alright, let's get started with the arrange first of all. So you have already seen this np.arrange. It generates their, a set of numbers like an array here. So this is one dimensional array. And previously we have seen you can use here a reshape to make it into a two-dimensional array. Well, so this part let me just explain you. In fact, I didn't explain you that previously. So if you try to reshape something which does not fit with the number of items in which you want to reshape, then you will get the error something like this. So what is this error? So this error says that you have your one-dimensional array, something like this, and this one-dimensional array have a total 9 numbers only. Alright, and now you are trying to actually reshape this one-dimensional array into a two-dimensional array, something like this, and that part you are saying that 2 multiplied by 5, which says that the 10 item. Alright, then obviously it's pretty much clear that any array which have 9 number, that cannot be reshaped in a 10 number, right? So this array can be reshaped in only 9 numbers, or anything which can actually, only 9 numbers actually in any shape. If you multiply all these together, then that must have 9 numbers, all right, 9 items only. So that can reshaped only in those many items. So this will throw the error, but as soon as you put here a 3 cross 3, this is gonna work here, right? I hope that this made you clear that how you can use reshape. Let's see how you can use the rearrange method. So currently we have our arrange method 1 to 10, and this also gives you actually the step here. But if you try to use here some step something like this, you get something like this. So in this and in linspace, let me just show you the difference together, then I'll explain you. So you have something like this where it starts with the 1 to 10, and then you have 0.1. Now you see the difference here, what happens. So in this it says that there is a start, stop, and then the step size. So basically it says that the difference between these numbers is equal to this number. But in this case what happens, you have start, stop, and thereafter it says that how many numbers you want in between these, right? So here you see the numbers here. Let's say now I say I want here 100 number. Alright, so it is going to generate something like this 100 number. I can say I need 99, or I can say that I need 90, or I can say that I need 89, or I can say that I need 91. So with this, what you can do, using this linspace, you can define that how many values you want in between these two numbers. But with np.arrange, you can say that how much difference you want between these two consecutive number. So this is the basic difference between the arrange and linear space. Let's see what's the use of repeat. So let's say you have your NumPy array as D1, or you are working some ML algorithm and you just want to repeat your data so many times. Alright, so same kind of the data. So that is where you can use the np.repeat. You can write here np.repeat, and then inside that you can give there the array. So I want to repeat D1 how many times? 2 times. So now you will see 1 1 2 2 3 3. So what is happening here? Basically you have your D1 here 1 2 3. So all these items individually which you are seeing, these items are getting repeated 2 times, right? So 1 1 2 2 3 3. So that is how this repeat work here. Let's see how the tile work here. So I have here np dot tile, and then you give your D1 and you say here 2. So do you see here the difference what happens? So if you use this repeat, in repeat these individual item gets repeated, but if you use here a tile, then this whole item, or this whole object is getting repeated 1 2 3 1 2 3 like that. So this is the basic difference between repeat and tile. Similarly, you can try it out for the two-dimensional array as well. So you can write here np dot repeat, and then I write here a D2, and then I say that I want to repeat it 2 times. So we had here a D2. In fact, where is our D2? So we have here a D2. So this is our D2, and now this D2 we had repeated it 2 times, and because of that this D2 actually got here the flattened, got this actually the flattening has automatically happened with this repeat. The similarly you can check here with the tile as well. Okay, so the np dot tile and then D2, and then 2 times you want to repeat, and there you get. So do you notice here the difference between this and that? Let me just show you here D2, and then I'll explain you why with this repeat this flattening has happened but not with the tile. So repeat has there another parameter that says that on which axis you want to repeat. So by default it actually flatten your array, and then also it returns there a flatten array. You can provide here axis, so like axis is equal to the 0. Now you will notice here that at 0th axis, alright, at 0th axis this repeat is happening here. So you had here 1 0, now it is becoming here 1 1 0 0 2 2 5 5 3 3 6 6 like that. And if you provide here axis is equal to 1, then it is going to repeat on columns here. By default it says that here it returns a flat output array if you do not provide here axis here. But in case of the tile, this whole thing is actually getting repeated a multiple time here. Alright, so this is all about in this lesson. I'll see you in next one. Alright, let's go ahead and see how you can use here random numbers. Well, so initially we had discussed that random number have very useful properties here. So random number can generate numbers randomly distributed throughout the sample space. Let's say you want to generate random number between 0 to 1. You can provide there the values start and end value, and then you can say that what type of random number you want, whether you want uniform random number or you want to generate normalized random number, or what type of random number you want. So these things random number can do easily. Random number can generate the numbers between the predefined values here. So let's go ahead and see how this random number actually works here. So I'm just going to say here random number generation. Well, so first of all, you can call random number module from the NumPy using np.random, or you can simply say here from NumPy import random. So once you import random, thereafter you can call this random, and then you can call other random methods after this random. For example, you can say here random dot random, and then you can give the values which you want to generate. Let's say I want to give here a size of 3 cross 3 random numbers generation. So by default this random number is going to generate all those values between 0 to 1. Alright, and these values are going to be float. Every time you run it, you will see here a different initialized value here. So this is actually a very helpful in machine learning algorithm. When machine learning weights are initialized here, let me just show you here, ML weight initialization. Let's search this, I'll show you actually. So when this ML weight initialization happen, I'm not able to see that ML weight matrix. Let me just see that. Well, so just take any the weight matrix here, for example. So whenever your ML model gets initialized first time, you see there these ML model gets initialized the first time, so weight matrix is prepared here. So by default these weight matrix values are assigned here randomly. So every time you restart your machine learning algorithm or you run it, so these weight gets initialized randomly. And these methods are actually used there to initialize the random weight, and this is very helpful actually. So every time if you initialize your ML weight randomly, then it actually avoids to stuck your ML model in any local minima. So there is very high chance that your model will converge. If sometimes you might have also felt that if your model is not doing good, you just restart your notebook and thereafter you retrain and you find that your model is doing good. So that happens because of this random initialization. Sometimes your random initialization happen in such a way that your model performs poorly. But next time if you initialize that, then your model performs good. Alright, so that is how you can generate these random number using random.random. Let's see how you can generate random number for the integer values. So you can write here random.randint. So with this you can generate the integer values. You can provide here low and high value. So I provide here 0 and then 100. In between these I can get here random values, that is the 100 here, 66 here, 67. So this randint by default gives you a single value, but if you provide here a size, it can give you a array like we have seen here. So let's say I want 3 cross 3, so it will give you result something like this. Okay, let's see how you can use the rand value. Okay, rand method from the random. So you have random dot rand here, and then this says that random value in a given shape. Alright, so basically this random dot rand and this random dot random, all these are kind of the same thing, you can say. So you have random dot rand here, and thereafter inside this I say here 5, and you just run this. You will notice here that in between 0 to 1, 5 random values are actually initialized here, right? And distribution is again in between 0 to 1, and its distribution is actually uniform here. That means the probability of number getting generated between 0 and 1 is same at any space here. So that is a uniform random generation. Alright, let's see how you can use a normalized random generation. So for normal data, what is a normal data? You first need to understand that you have your random number like this, let's say, and you are saying here you want to generate a normalized random number. So basically in that, if there is a mean here somewhere, then all the numbers, the most of the numbers, you can say that those number will be concentrated around the mean only. Okay, so let's see how you can generate this normalized random number. You can generate that using np dot, in fact we already have imported random, so you can say the random dot normal. With this you can generate a normalized random number. Then you can say that between which point you want. I want between 0 and 1. How many times? I want 1000 data points between this. If you generate this, maybe not 1000, maybe let's take 10 only. So if you generate this, you will notice here that these number which you are seeing currently, these are actually concentrated around a single point, that is around the mean only. So what is the mean here? So every time actually you do this, this will get changed here. So I'm just going to say here x is equal to like this, and thereafter you print your x like this, and then you can say that here x dot mean like this. So here is a mean. Now this number, if you plot this number, you will notice here that this number generation will happen around the mean only. So these number which we have defined, these are not actually the minimum and the maximum. So this says that these are actually the location. So this first one is the mean location, and another one is actually the scale here, right? So you might wonder that our mean is not actually the 0 like we have defined. The reason is here we have generated only 10 value. But if we generate a very fairly large value, thereafter if we check our mean, then it will move toward the 0. So what do you understand with this? That after generating our random number, we see that our most of the number here, I mean this whole generated sample, have a mean 0 here. Let's see what's the standard deviation in this, right? So default standard deviation here I have assigned here 1. Now I'm going to check that standard deviation here. So I find out here that standard deviation is almost 1. But as soon as I make here standard deviation 10, and thereafter I notice here that standard deviation is toward the 10. So that is how you can generate the normalized random number. If you plot this random number on the graph, you will be seeing similar to this, this distribution. All right. So what is the what is the use case of this in actually in the machine learning algorithms? You see, once you are given a data set, something like, let's say you have data set like this, and you split your data set into two parts. The first data set, you say that it is the trained data set. Another data set, you say that this is the test data set, right? So this whole array, you actually randomly, divide this array into the two set. That is where you set there a seed of a random number. If you don't set the seed of the random number, then every time you run the test and split in your ML data set, this will split into a two different set every time. So if you want to keep consistency between the multiple runs, that is why you do their seed setting. For example, you can test that as well here. Currently we have here np random.normal 10 times. Every time we run this, we are going to see the different result here. But as soon as we put here random dot seed, let's say I'm just going to put any number, or any seed number you can put, and thereafter I copy this and put it here. I run this, and I run this multiple times, right? Do you see this? I'm running it so many times, but I'm not seeing any change here, right? So this is the beauty of this seed, and that is how this is going to help us in our machine learning algorithms, right? So we will be using this seed value a lot when we will be doing our train test split. At that point, we will set there some seed value, so that if we run our model so many times or multiple times, our train test split data will not change the pattern. So whatever the pattern is used the first time, it will use the same pattern every time I run my algorithm. Alright, so this is all about in this lesson. I'll see you in next one. Let's go ahead and see how you can do conditional selection in NumPy array. So there are where statement in NumPy array which you can use to do conditional selection in a NumPy array. So you can define their set of condition, and then you can use this where statement inside that NumPy array to select a particular set of rows or particular set of the column in your NumPy array. Other than that, we will be also seeing that how you can find out the index of maximum value and minimum value. So these two things are going to be very important for us in our feature selection process, anomaly detection process, and model optimization parameter process in machine learning algorithms. Other than that, we will be also using these to find out the classes in our probability distributions as well when we start building our ML models. So these two things are going to be really very important, especially this argmax is going to be really very important for us. Okay, suppose that we have our array as a D1, and inside this array you need to find out all those rows which have values more than 2 or 3. Or what I can do here, in fact I can create a little bit more larger array. So I'm just gonna make here 1 to 20 like this, and then I run my D1. So this is a little bit larger array, and on this array I want to find out all those rows or all those values which are greater than 10. How I can do that? So it's pretty much simple. You can write here np dot where inside this you can put your condition. All right, you see there how this is going to be there. So inside this you put their array and then you can put your condition, right? So basically I'm gonna say here my D1 greater than 10, and then I put my data value, that is the D1 here. All right, let's run this and see what we get here. Okay, one more thing here we are missing actually, that is here replace these the values after meeting at which those values which meets these conditions, what we are actually going to replace those, right? So you see there we have replaced those with the 0. So basically what happened here, all those values which are greater than 10 we are keeping those as it is, and other values which does not meet this condition we are replacing those with the 0. So this is how you can use this np dot where in your code. Let's say you want to find out the maximum of a given array. How would you do that? So you already know that to find out the maximum, but the question is here, how would you find the index of the maximum value in your array? So to find out the index of maximum value, you can simply write here np.argmax, and then you can say that here D1. So with this you will be getting the index of the maximum value. So this is index there. You can simply write here D1. You can give your index number here. You will see there this is the same value which you had got using max. Similarly, you can use their arg minimum. So you can write that like D1 dot minimum. So this is minimum here 1 in your array which you had earlier, not this one. Yep, this one. So 1 is a minimum. What is going to be index of the minimum value? That you can find out using here arg min value, arg min method that says that it is at 0th index here. All right, perfect. Let's go ahead and try to simulate here a feature selection method, how we can use where condition, mean condition and argmax condition. Basically what I'm saying here, how you can combine all these conditions to do a feature selection. So here we are gonna set a condition, or just for our understanding for feature selection, that those values which have high mean, we are considering those as a good feature or important feature. So let's say we have our two-dimensional array. In this two-dimensional array, those features, the features are arranged as the column. So those features which have high mean value, we consider that those features are an important feature. All right, so let's see which column have here, which column is here the most important column or the most important feature. So to find out that, you have to first of all get here the mean of this. So you write here np dot mean, thereafter d2 on axis is equal to 0. So this we are going to get the mean on column data. So this is the mean, the column wise we have got like this. You can print your D2 for the reference as well if you want. So I'm just gonna print that D2 for your reference. So here we are getting all these mean column wise. So visually we can see here that this column have a maximum mean and this is the most important column, right? Visually we can see that, but how we are going to select this using code. So you can simply write here now np.argmax, and then you can just simply put this inside that, and then you just run this, you will get here this one. All right, so the second column which you see here, that second column have the most important features. And to select this, what you can do here, you can simply write here a D2 and then select all rows. Thereafter you can select the column number 2 here, basically something like this. So you have here 3 and 6. All right, do you see this? 3 and 6. If you want to make it dynamic, you can select this one. Thereafter you can put it something like this one. So now it becomes here a dynamic, right? Even though if you change your D2 structure, so now you don't need to put these indexing like, you know, a permanent indexing. You can keep it as a dynamic indexing. So with this, even though if your D2 changes, so this method will not change, right? So this will always give you correct and right result. All right, let's see how we can apply where on our multi-dimensional data. Suppose that we have our 3-dimensional data as a D3 here, and in this we want to replace all those values which are even with 0. Then let's see how this is gonna work here. So you can simply write here np dot, let me just print this D3 for our reference. Thereafter you can write here np dot where, and thereafter inside this I write D3 modulo operator 2, and then I set here equal to 0. So if this condition is true on D3 data, then replace, you know, those values with the 0 here. So do you notice here that? Okay, so what is happening here, all those condition, actually I said that we need to change, I mean we need to replace our even with the 0. So in that case you have to put here not equal to. So what happened with this, whatever condition does not meet this, right, or whatever item, all right, does not meet this condition, those will get replaced with the 0. So if you run this, you will notice here that all even values, right, all even item in your array got replaced here with 0. All right, so this is how you can work with the where, argmax and argminimum. We are going to, we will be using argmax a lot with our ML models when we start doing ML model building and prediction. All right, I'll see you then. Let's go ahead and see how you can save and then reload your pre-processed NumPy arrays. Let's say you have your array, D3 array, and you have pre-processed this array like we have seen previously. Let me just show you here. So you have something like this, let's say D3P, I'm saying that is the D3 pre-process array. And now you want to store this array so that you can use it, you know, for later purpose. You know why we want to do this? So if you are working with machine learning model, you would be working with a very huge data, right? So you would be having like, you know, the very huge data. Let's say this data have like, you know, the terabyte data. And you have done the pre-processing on this terabyte data. So I'm saying that here you have done a pre-processing here, and this pre-processing took like, let's say, the 10 hours of the time. All right, then you apply another ML model on this pre-processed data. So you applied this ML model today, but now the question is here, let's say if you apply your ML model tomorrow, or someone else in your team try to apply ML model on this terabyte data, whether the person will again take that 10 hours or not, right? So if you follow this whole process, then obviously again before person reaches here to the model point, then it will again take 10 hours. So what is the solution? Solution is here, you can save your file, right? So you can save your file here somewhere, right? So you can say that here, save pre-processed file here, and thereafter you can load your data. So not from here. All right, so in fact let me just write it in more better way, not from here, but you read your file from here. So if it is first time, then obviously you can read your file directly from here. Otherwise, if it is the second time or someone else is working on the model, then the person can read it from here itself, right? So the person can actually, the person can avoid this 10 hours of the time. So in that way, what will happen here? So going through here, this data actually already, this data is already stored here. This data is already stored here. So the person don't need to do this pre-processing the next time. So this is the, this is how you can make this, a very time saving for you if you store your pre-processed data in disk. Only storing and reading your data, that will time get consumed. Otherwise it would be pretty much fast here. Perfect. Let's go ahead and see how you can store this. Okay, so to store the NumPy array, there is the file format which is known as a NPY. This is NumPy file format. This one is NumPy file format. So we are going to store our NumPy array in this file format. We are assuming D3 is our terabyte of the data. After pre-processing, we have got our data something like this. Now we are going to store it here. We are going to store it inside here data directory. So I'm just going to make a data directory. You can make it with the import os. Thereafter you can write here os dot make dirs, and then I say here data, and thereafter I say exist OK is true. That means if data directory is already there, then it will not throw the error after, during the creation of the data. For example, even though if you run it multiple times, it will keep this data, it will not throw the error. All right. Now I'm going to store my D3P in this data folder. So I write here np.save, and thereafter I need to write here the file name where I want to store, thereafter the array which I want to store. So the file name here I say data /d3, and then I say here p.npy. Alright, this is NumPy array, and thereafter I provide that which file I'm going to store here. I'm going to store d3p. Let's go ahead and run this. Now you will notice this NumPy array is stored here, right? And this NumPy array as of now we cannot open this here. Alright. So this NumPy array, you can also store it into the text format as well. So to store it in text format, you can just copy and paste it here. Then you can say that here np.savetxt. Now this is going to be saved as a txt file format. You just run this. Thereafter there is the error, and this error says that it expect 1D 2D, but it got here a 3D array. And obviously it's very much obvious that we cannot actually store a 3D array in a text file format, because in this text file format we can just visualize the two-dimensional data. So what to do with this? Either we can convert our this D3P as 2D or 1D data, or we can store slices of this data. So if I say the slices, that means here we have our D3P data. So this one is one slice, and here another one is this second one is the another slice. So basically these are like the layer in your multi-dimensional data. So this one is a two-dimensional data. This can be stored as a single slice, and this one can be stored here as the single slice. So let's go ahead and store it as a single slice. So I'm going to write here, first of all, for I, and then I'm going to write here our 2D data. So I'm going to write here D32. Okay, so this is the 2D data of this our three-dimensional data. In enumerate I'm going to use here, and thereafter I use here D3P. All right, and if you print your D32 here, so what you will get here, you will be getting your two-dimensional data two times, right? Because those individual data here, these are getting here inside this D32 two times, right? For each iteration here, and this I says that which slice we are currently reading. So here we have a first slice, and then we have second slice. Now we can store this here, right? So I'm going to store here np.savetext d3p, and thereafter I say here slice, and then I put my I here, so slice number, and then I'm going to put here as a string formatting here. Alright, something like this I can do. Then it says that again some problem. Obviously this I cannot store. I have to store here D3 2 like this. I just run this. Now you will notice here you have got the first slice data and here you have got the second slice. So that is how you can store the three-dimensional data in your file as well. So when you read this data, then you can combine all these slices together so that you can construct three-dimensional data or a multi-dimensional data. Let's go ahead and see how we can load our data. So we have already stored here our two-dimensional data here, D3, not this one. Yeah, this one actually is three-dimensional data, but let's see this NumPy three-dimensional data, how we can actually read this one. This one is empty, so I'm just going to delete that. So I'm just going to read this one from the data, I mean from the file itself. So you can assume here that once you have stored your file, then how you can read this file for the model training. So I'm just going to show you that. You can write here np.load, and thereafter you can put the file name which you want to load here. So I write here data, and then you have here d3p.npy. So you write this one. Now you will notice here that we have got the result here. You can just simply run it here. You will notice this is the three-dimensional data, right? If you check here the shape, you can get here this is exactly the same data which we had earlier, right? Perfect. Let's see how you can load this txt data. So like we had our save txt, similarly we have our load txt here. You can write here np.load txt, and then you can give the data which you want to read, I mean data file which you want to read here. I say here d3p, and thereafter we have here slice underscore 0. I'm just gonna read here the first slice, something like this. So I get here the first slice. So this one you can say that this is slice 1, and similarly you can read a slice 2. I'm just going to copy this and paste it here, and then I'm going to read this slice 2. I have got both slice here. Thereafter you can combine these together to create the three-dimensional data. np.array, and then you can put it inside the list here, S2 and S1 and S2. Here you will see, right? Perfect. So you have here actually combined these txt formatted the data. Those were like the 2D data, and now we combined it together to make it a three-dimensional data. You can check the shape of this here. This is completely the same shape like we had earlier. Perfect. So this is all about in this lesson. I'll see you in next one. Let's go ahead and see how you can concatenate and sort NumPy array here. So what is the concatenating and sorting, and then the V stack and the H stack? This you can understand with an example here. Let's go ahead and do that together. So let's say you have an array, something like this, a NumPy array. Alright. So there are two types of stacking we just saw there. One is the V stack, that is the vertical stack, and another one is the H stack. So let's say you have these array, and hypothetically assume now you have two array actually. Alright, so if you combine these two arrays something like this, then it becomes a V stack, right? You are stacking these array vertically. But if you combine these array something like this, then this becomes here H stack. That means you are stacking these horizontally. So this one you see there, this is row wise stacking, right? This is becoming here row wise stacking. Whereas what you see here, this becomes column wise stacking, right? So this could be useful when you are doing machine learning algorithms preparation or model preparation. So you have your feature space. So if you have additional rows for a particular feature, then you can do a V stacking. But if you have additional feature in your data, then you can use their row wise stacking or H stack. Similarly, you can use the concatenate to add multiple array together, either with the column wise or with the row wise. Let's go ahead and see that with the practical example how we can do here. Okay, so we have our array here, D1 array. So as of now, I'm just going to put my one-dimensional array as a D11, and here I'm gonna create one array, that is np.arrange, and this array I'm going to create in between 1 to 5 here. Another array I'm going to create again here, that is going to be the d12, and this array is again going to be something. Let me just copy this from here and then paste it here. This is going to be 5 to 10. So this is our D11, and here we have D12, right? So 1, 2, 3, 4, and 5, 6, 7, 8, and 9. So we are going to work on these two array, and then I'll be showing you what result you are going to get with the concatenate, and then I'll be showing you with the example. All right. So here you can write np.concatenate. Thereafter, inside this concatenate, you can write those array together which you want to concatenate. So those array you have to write inside a single, inside a single tuple or a list. You can write that I want to concatenate D11 and D12. So you will notice here that a row wise concatenation is happening here, right? H stacking kind of things has happened here. So 1 to 4 is array 1, that is the D11, and 5 to 9, that is the array 2, that is the D12. So these got actually the concatenated here together, right? Let's say, can we get the same result using the H stack? So I write here np.hstack, and thereafter inside this H stack, if you put your cursor, you can get the details. Currently it doesn't seem like that detail is coming here. So you can write here D11 and again D12. If you just run this, you are getting exactly the same result here. So like you have seen here in the concatenation, exactly the same result you can get with the H stack. Let's see how you can use here our vertical stack. So like we have seen our example like here. So how we can actually vertically concatenate these matrices. So you can simply write here np.vstack to vertically concatenate these matrices. So we have D11 and then D12. Now you will notice the result here seems like must be the same axis. Okay, something is wrong here. Let me just check that what went wrong. Wait. Well, the problem is actually coming because of this here. So you have 1, 2, 3, and 4 here, but here you have a 5 element. So because of this, that problem is coming. So in H stack, that problem doesn't come. But if you try to concatenate this vertical concatenation then it will create a problem. So for that, I have to actually fix this. So 1 to 5, and thereafter I can take it from 5 to 9. All right. So with this will produce now a same dimension data here like this. This will work perfectly. Now you run this, you will notice here that the first matrix now got actually concatenated here below here. I mean, the second one got concatenated the below of the first one. So that is how this vertical stacking work here. Let's go ahead and see how we can do the sorting. All right. So we have our array D11 and we want to do here a sorting, or we can see here we have our D1 and it is already in sorted order. Now I'm just going to distribute it randomly. That you can do with the np.shuffle, np.random.shuffle, and thereafter I'm going to provide my D1 here. So if you do like that, now you will notice here this D1 is randomly shuffled NumPy array. So it is no more sorted array. Let's say you have something like this. How you can sort this array? To sort this array, you can simply use here np.sort. So you can use here np.sort and then you pass your D1 array. Thereafter you will notice this array is sorted here. Thereafter you can take this out and then you can pass here whether you want to reverse it or not. So if you want to reverse it, now it will be sorted. Just a second. Something is wrong with. Okay, so doesn't seems like it takes that reverse. So we can utilize here other method to sort it out. So I can put here starts and then -1 like this. Now you will notice here that this is reverse sorted array. All right, so this whole thing you can use as a forward or ascending order sorting, and you put this one to make it descending sorting. All right, let's go ahead and see how you can use the arg sort here. So what is arg sort here? You have np dot arg sort here, like we had here arg minimum and arg maximum. Similarly, we have here arg sort. So this arg sort is actually something which works on the index. All right, so you have here np dot arg sort, then you have your d1, and you want to find out the index of those item if they get sorted, right? Basically, you have your d1, which is unsorted array like this, and you want to find out those index if you sort this. All right, if you sort this array, then how these index will appear. So that one you can do with the np dot arg sort here. So you can just put your d1 here. This is going to give you the result of those indexes in a sorting manner. So basically it says that here 7, that means 0, 1, 2, 3, 4, 5, 6 and 7. So this one is the first one, right? And so on, right? That is how it moves here. At the 14, that's mean here this one is coming at the 14th place, and then there is a 3. So 0, 1, 2 and 3. This one is coming from here, right? So this one says that arg sort says that if you sort your array, then how the index is going to be there, right? Perfect. So this is all about in this lesson. In this lesson, you have learned about shuffling, you have learned about the V stack, H stack, concatenation, sorting and arg sorting. All right. So I'll see you in next one. All right, let's go ahead and see how you can work with the date time in NumPy array. Previously, we have seen how you can work with the date time using date time module in Python. Now we are going to see how you can work with the NumPy array. So in NumPy, you have a date time 64. That is the module here. You can write here np dot date time 64, and inside this you can give your string date time, something like this, let's say. And then if you run this, you will get this one is actually shown here as the date time object, but it's a NumPy date time object like this. Now you can perform date time operation on NumPy date time object, right? Similarly, you can create the array of these date time object. For example, you can write np dot array like we have been doing earlier. So I'm just going to write here 224 and some, let's say the September 01. Thereafter I write here 224, and thereafter I write here October, 1st October, and so on. And if I run this, you will notice here that this is not a date time object as of now. So to convert a date time object, you have to give your date type specifically here, right? So that you have to assign and that you have to tell it here. So the date type I want here, date time, data type I want here, date time 64. So if you run this, now it becomes here as a date time object. Perfect. Let's go ahead and see how you can do a arithmetic operation on a date time objects. Let's say you have this array. I'm saying a1 is equal to something like this. Okay, and I want to find out the date difference between these first and second, right? How would you do that? You have a10, that's the first item, then you can do the minus of the a1 and the second item like this. You will find out here that there is a gap of the 30 day, but that is the minus, that's the negative. That means this date is coming first, this September one is coming first, and then obviously October is coming in the last. But let's say if you define here our November as well, like 224, and then you write here something like this, and you try to do like this a1. Let me just keep this as it is, then I'll explain you what happens here. So you have a1 and thereafter you have here a2. You will notice here that it's a 31 now. So basically now your algorithm or NumPy array automatically knows here that this October month which you have here currently, that have a 31 days in the month, and here September had just 30 days. That is why the difference here 30, but here you have a difference of 31 days. Or you can write it like this. A2 minus A1 and thereafter like this. Now you are having here a positive date. Why? Because if you subtract this November 1st with the October 1st, then obviously you will be getting there 31 days. So that is how you can do this date time operation on your NumPy date time object. Perfect. Let's go ahead and see how you can generate a machine learning kind of, the data with this date time system. I mean date time objects. So let's say you are working with the time series data and you have a list of the dates, and for that you want to generate the data. How you can do that? But before that you have to generate the date, right, for some range. Let's say for this whole year you are working on some time series data and you want the data for this whole year. So what you can do, you can simply use np.arrange like we have been using here, np.arrange, and then you can say that the date here. So I say like something like this, let's say from the 1st September 24 to 25, and then I write here till, let's say, the 31st October of the 25, right? So I want the data between these, and thereafter I have to tell here the date, the data type in which it need to generate the data. So here I have to tell the date time 64, and I want it to generate the list of dates between days. That is why I put here D. If I run it, now you will see here that this is generating in a date wise, right? I mean day wise. So there would be SAPE, that would be 365, right? If you check the SAPE here, you will be getting 364 actually. So seems like we have 364 days only in this whole 1 year. All right. Thereafter I write here A2 as equal to like this. So now I have got my A2 array, and for this A2 array now I want my NumPy data. Alright, so what I can do, I can simply write here, let's say I want my data, so I write here data is equal to np.random, and thereafter I want to generate here the random numbers. So np.random.random, and thereafter I can generate all the data with the length of A2, or you can say the SAPE, whatever you prefer. Then you just run this, you will get your data here, right? So you see the data SAPE, what is the SAPE of your data? It is exactly the same like you have your A2, right? The SAPE of this A2, that is going to be the index, and this one is going to be, this one. So this A2 can be the index and this can be your data. So this is how you can generate, sample data if you are working with the time series data in machine learning algorithms. Alright, so this is all about in this lesson. Thanks a lot for watching this. I hope that you have learned a lot about the NumPy array. A lot of things we are going to use in our coming lessons where we will be building our machine learning model. So these algorithms or these methods we will be needing there. So I'm sure that you have learned here a lot, and please do not forget to leave your feedback. If you have any question, you can ask that, and please do write a review. And once you complete this course, take the certificate and then post it on LinkedIn. You can tag it there. You can tag me there as well, so that I can shout out for you. Thank you. Bye bye. Take care.